In today's class, we'll learn about inverse Laplace transform by complete squaring. First problem is find the inverse Laplace transform of s plus 1 divided by s square plus 6s plus 9. The solution of this problem we'll see now. Problem is find the inverse Laplace transform of s plus 1 divided by s square plus 6x plus 9. So solution. So we need to find inverse Laplace transform of s plus 1 divided by s square plus 6x plus 9. So just see, is it in any of the standard form denominator? So it is already a perfect square, then we no need to go for any manipulation in the denominator. If it is not, we have to go. So here what I can feel here, so denominator can be converted as s square plus 6. I will write what here, 2 into s into 3 plus, and already 9 is nothing but what here, perfect square, that is I can say that 3 square. So I can say that a square minus 2ab, and so b value is nothing but 3, so already b square. So the given thing is nothing but in the form of a plus b whole square form, denominator form, so which is nothing but inverse Laplace of s plus 1 divided by s plus 3 whole square. So therefore, so denominator work is over, so numerator we need to rearrange. So if it is s plus 3, so we also needed one of the term here as s plus 3. So to make that arrangement, so L inverse of, so s plus 1, we will write it as what here, s plus 3 minus 2. So 3 minus 2 will get back plus 1. So I had made what here, arrangement, and denominator as it is. So this what arrangement, 3 minus 2 is nothing but 1. So s plus 1 will get back. So this arrangement for, so we have to make this arrangement in a such a way that whatever s plus 3 is there, means whatever terms we have, the same term should fall on the numerator also. So for this we'll put a bracket and we'll separate now. So therefore inverse Laplace of s plus 3 divided by s plus 3 square, and another term minus inverse Laplace of 2 divided by s plus 3. We'll separate like that. If you take the LCM, you will get back the same again. So therefore on simplification, but this is the same terms, so this cancels among this one. So we'll get L inverse of 1 divided by s plus 3 minus 2 is a constant, L inverse of 1 upon s plus 3 square. So here we don't have any property, this one we in the first term we don't need any property and all, so we can apply direct formula. So that formula is what here, inverse Laplace of 1 upon s plus a is nothing but e raised to minus 80. That formula will apply for the first term. So for the first term, what happens here, inverse Laplace of 1 upon s plus 3 is nothing but e raised to, so we'll work out like that now. So we don't want this step. So here, so we'll go back to this step. So this, once we have made this arrangement, that arrangement is what here, s plus 1 we have taken s plus 3 minus 2, and we have made s plus 3 as a bracket. Now first we'll apply shifting property. So by shifting property, it is nothing but shifting property, the value of a is minus 3 and s plus 3 changes to s. So what happens to this step, we'll see now. So which is nothing but e raised to minus 3t into L inverse of, so s plus 3 changes to s, it will become what here, numerator will become s minus 2 divided by s square. So this step what we have made, we don't want this, so we'll simplify this now. So therefore, so e raised to minus 3t, so L inverse of, so we'll separate this one now. So inverse Laplace of s divided by s square minus inverse Laplace of 2 divided by s square. So which is nothing but finally, so on simplification, so one more step, e raised to minus 3t bracket, so s and among this one is cancelled, so L inverse of, we got 1 upon s here, minus, so 2 is a constant, inverse Laplace of 1 upon s square we left here. So therefore finally e raised to minus 3t, so inverse Laplace of 1 upon s is nothing but 1 minus 2 times, so inverse Laplace of 1 upon s square, so we know that one of the formula what we have seen, so formula is inverse Laplace 1 upon, and if n value is 1, 1 upon 1 plus 1, it will become 1 upon s square. So what happens, n value is 1, so therefore t raised to 1 upon 1 factorial, so n value is 1 here, so because 2 can be written as 1 plus 1, so n value is 1, so therefore t raised to 1 is 1 divided by 1 factorial. So which is nothing but e raised to minus 3t into 1 minus 2t. So this is the answer of given inverse Laplace transform.